Hello. Today we are going to be looking at the recursive rule and explicit rule for arithmetic sequences. Now, while we are going through this, I want you to look at your student pages. There is a page on vocabulary there, so look at that. There's going to be some words we're going to be covering today specifically. Arithmetic sequence, common difference, explicit rule, tabular, subsequent, or consecutive rows. Those are things that we're going to be looking at. And subscript. So let's come on over here to arithmetic. We went ahead and pre-populated some stuff here. So there's a reading in the book, and I just took this data here, and took it from a horizontal to a vertical one that we're much more familiar with. And so I just put down our subscript, our input. Instead of x and y, it's now going to be our a sub n, and our output, I know it's going to be tickets earned or whatever. So a sub n just means that we're talking about a sequence and not a function yet. We will eventually get to a function. There is a movement through here that we're going to be working with. And we always start out with our recursive rule, because it is how mathematicians look at data as small groups of data to determine what is going to be the overall function. Okay. All right, so there's also a reading in there, and I went ahead and circled some of the things that you are going to want to know about. Let me go ahead and see if I can get this. No, it won't move. Just slide it on over here. So we got the recursive notation. That is where you're going to get that wording, and it's to generalize an arithmetic sequence. Arithmetic sequences always have two parts. You need the a sub 1 part first, and then a sub n. So you're always going to have two parts with an arithmetic sequence. We're adding 4 every time, so we increased. That is an add-in, and the common difference, whether it is a positive direction or negative direction, it is a common difference. And we're using a table, and we're looking at consecutive terms. Consecutive means 1 followed by 2 followed by 3 followed by 4. Okay. All right. And then you're going to notice in the textbook also there are some golden colored call outs that you want to pay attention to. So in this case, it is a subscript. So we use a subscript 1 or a sub 1. And that just tells us that it is our initial value in this case of this table. What did we start with? All right. So up here, I'm going to move that table up just a little bit so I can have some space to work with. Come on. Be nice. Sometimes it is and sometimes it isn't. Okay. So now I'm going to come over here, and we are going to just, again, I'm going to grab my, we've added 4, added 4, added 4, added 4, added 4. Plus 4 is our common difference. We took our ending value and we subtracted from our beginning value. It is an increase, and it is an increase of 4 each time. So that is our common difference in this case. All right. So for our recursive rule, we're going to write down that a sub 1 was 11, and then a sub 2 is 15. Now, how did we get a sub 2? Well, a sub 2 really is a sub 1 plus 4. And then a sub 3, well, how did we get a sub 3? A sub 3 was a sub 2 plus 4. And a sub 4 is, of course, a sub 3 plus 4. So this is where they're getting that. Here's our n. What is this? This is n, which is 4 minus 1, gives us 3. That's why they write it that way. Okay? All right. So that is everything for our recursive rule. Now we're going to take our recursive rule, and we are going to find our explicit rule. Let's do it maybe in, do I have purple today? Yeah, I like purple. All right. So let's say he plays 25 games. I do not want to have to do that recursively 20 more times. So instead, what we're going to do is that we're going to find a way to go directly. Explicit means direct. You give explicit directions. You have told somebody directly what to do. We want to go to a sub 25 without having to go through all that recursion nonsense. So we're going to use our recursive model to figure out our explicit rule. So our recursive model was a sub 1, which was 11, and then a sub 2, which was 11 plus 4, and then a sub 3, which was 11 plus 4 plus 4, and then a sub 4, which is 11 plus 4 plus 4 plus 4, and I'm tired already. Okay, so now what can we do to find this? What can we do to find our explicit rule? Well, our explicit rule states we need a sub 0 and so we can use a sub 0 so that we can tie in our n right here, our n value, to an equation. So what I'm going to do to find a sub 0, which is how we usually do tables, is that we're going to take 11 minus 4, which means 11 minus 4 would be 7. That's what we're going to start out with in our table for our explicit rule. All right. Yeah, so this textbook is really good for the most part. What we have here? Okay, I want this one. Our textbook, for the most part, is pretty good, but there are some things that it leaves out, and that's why I'm bringing this in. So again, we're going to need two pieces of information for our explicit rule. That is going to be, we need a sub 0 and the common difference. We now have both of them. So for the explicit rule, we're going to take a sub n is going to be any number is going to be equal to our a sub 0 plus our common difference, which is going to be represented by d, times whatever our term number is in this case. Okay, so let's use our first one, a sub 1. All right, so a sub n is going to be equal to 7 plus whatever our common difference was, which was 4 plus times n. So let's check that for our values from our tables. This is how we use our recursive rule and our explicit rule to verify this. So let's do a sub 1 and let's do a sub 4. A sub 1 is 7 plus 4 times 1, which is 7 plus 4, which is 11, which is what we should have had over here in our table. That's what we have. A sub 1 right there, a sub 1 and 11. Okay, and we said 4. So a sub 4. So over here, let's do a different color, and let's do this pretty blue one. A sub 4. Maybe a little bit thicker than. Like when they're too thin. A sub 4 is going to be 7 plus 4 times 4. All right. So 4 plus times 4 is 16. 16 plus 7 is 23. Let's go see if a sub 4 is 23. A sub 4 is 23 right there. So that's how we use our recursive rule and our explicit rule. Now we will extend this. We're not going to do it today, but we will find our function from our explicit rule. So, but that's later.